Hello guys, and today we're gonna be looking at multiplexers. So what are multiplexers? It's a device that selects one of several analog or digital input into a single output. Here you can see that you have 4 inputs and 2 selectors and only one output. So let's review what elements is made of. So you got a number of inputs, and then you got a number of selectors depending on the number of inputs, and only one output. Here we have a 2 to 1 MUX. We just got one selector because the selector can be 0 or 1. So those are 2 options. So the one's necessary to select both inputs. Here is the truth table for the element, and here is the schematic representation of the MUX. I'm gonna show you a really easy way to get the equation of any MUX, and you can have a 4 to 1, 8 to 1, 16 to 1. It's really easy with this method. We are just gonna apply the. Okay, so let's look at some cases, and here we have a 2 to 1 MUX, 2 inputs and 1 output, and just 1 selector. So the sum of products is here. The output is gonna be a sum of 2 products. Those products are made of the selector and the input. Here is the first one, and here is the second one. The underline in the selector means that this is negative. This equation is exactly what we have here. So let's look. When we get the selector in 0, the second term cancels out, and we just get the first one because S is negative and we got 1. So the output becomes W0. And in the other case around, when you get the selector in 1, then the first term cancels out because of the negate, because it's negative, and the output becomes W1. So it's really easy. Here we have a 4 to 1 MUX, 4 inputs to 1 output. It's the same principle, and we only add one more selector because with 1 bit you can represent 4 options. You need 2 bits. You got the 0, 1, 2, and 3. So in the first term you got 0, 0, 0, 1, 1, 0, and 1, 1. Okay, so basically what we need to do here is like put an index in each element. Here's the first one, second one, third one, and fourth one. But remember, we start from zeros, from the element 0. So it's 0, 1, 2, and 3. And by putting an index, you just gotta play with S1 and S2 to represent that number. Here you got 0, 0, 0, 1, 1, 0, and 1, 1. And like that, when you put those inputs, you get the first one, the second one, the third one, and the fourth one. It's really easy. Okay, in the next video, I'm gonna show you how you can put this up into hardware description language and in Verilog. So see you in the next video.